Hello everyone, today I will show you our experiment and our project about enhancing phishing detection with machine learning, a study on the effectiveness of feature selection techniques. In this experiment, we have three authors. The first author is me, Akbar Hamunangan, the second author is Danu Hasan Fatih, and the third author is Mr. Andi Sunyoto. And for our affiliation is Universitas Amikom Yogyakarta. And then, without any further ado, let's start with the first explanation of this experiment. The first explanation is about the background, research questions, and the objective. The background is phishing remains one of the most common cyber threats, with more than 142 million phishing link clicks detected in the second quarter of 2025, an increase of 3.3% compared to the previous quarter. Phishing attacks are now increasingly sophisticated through techniques such as domain spoofing and URL obfuscation, making them more difficult to detect conventionally. To address this, a machine learning based approach has proven effective in identifying malicious patterns in URLs. However, model performance is highly dependent on the quality and relevance of the feature used in the learning process. Therefore, this study aimed to assess the effectiveness of various feature selection methods in improving the accuracy and efficiency of machine learning models in detecting phishing sites. And for the research question is how effective are various feature selection techniques in improving machine learning performance for phishing URL detections. So for the objective, we comparing the performance of feature selection. After that, we evaluating the accuracy and efficiency of ensemble model, and then providing practical guidance for the lightweight and accurate phishing detection system. The next explanation is about the dataset and methodology. The source of our dataset is from open datasets from Kaggle with 11,430 URLs, and the class is legitimate and phishing. And for the class, we got the dataset is very balanced, like we can see on the class distribution image in this slide. And then the feature is 89 attributes, including lexical, structural, and external. And for examples, like URL length, number of special symbol, PageRank, and Google index. And then for the methodology, feature selection we use is like filter based method like ANOVA F-test and mutual information, wrapper method like recursive feature elimination, or we say it RFE, and embedded method like tree based feature importance. And for the machine learning models, we use random forest, XGBoost, LGBM, and CatBoost. For evaluation, we use metrics like such as accuracy, precision, recall, and F1 score. And for the efficiency, we use a training time and inference time. The next explanations will be the research workflow. We start with problem identification, and then research objective, data collection and pre-processing, and then after that is baseline modeling, using feature selection, model training and evaluation with feature selection of course, and the next is looking for the best feature selection and model combination, and then doing the hyperparameter tuning or doing tuning on the model, and then the final model and interpretation like for test set evaluation and sub feature important analysis, and then we got the conclusion. The next explanation is about the baseline results and after results. For the baseline results, before applying the feature selection method, the four machine learning models such as random forest, XGBoost, LightGBM, and CatBoost were trained using all 87 features. The features show high performance with an accuracy above 69%, with LightGBM recording the best result with accuracy of 69.9%. However, the use of all feature results in the conclusion of irrelevant feature and increased computational complexity. Therefore, these results serve as baseline for comparing performance improvement after applying feature selection. So after results, like we can see in the modeling after feature selection image, after performing feature selection, the model performance remained high with an accuracy decrease of less than 1%. The combination of CatBoost with ANOVA F-tests with 30 features produced the best performance with accuracy of 69.44% and an F1 score of 69.44%. Interestingly, the number of features was successfully reduced by more than 65%, making the model lighter, and more efficient without significant loss of accuracy. These results confirm that feature selection is capable of filtering the most relevant features and substantially improving the model efficiency. The next explanation is for the overall results. This section shows of the comparison of model efficiency with and without feature selection based on the training time and inference time. From the table on the left, it can be seen that feature selection with no FS in the top of image on the left, the model training time, especially for CatBoost, is still quite high, reaching around 12 seconds. After applying a feature selection, especially with the ANOVA F-test method, with 30 features, the training time is significantly reduced. Like we can see, XGBoost from 2.48 seconds to 0.30 seconds, LGBM from 0.62 seconds to 0.32 seconds, CatBoost from 12.5 seconds to 8.18 seconds, and Random Forest from 1.94 seconds to 1.31 seconds. The application of feature selection is not only maintain high accuracy, but also significantly improve computational efficiency. This makes filter-based approach such as the ANOVA F-tests ideal for phishing detection system that require fast training times and minimal resource. The next is model tuning. The model tuning we use is CatBoost model machine learning CatBoost with ANOVA F-test with 30 features. So for the hyperparameter grid search CV, the depth is 8, iteration is 500, learning rate is 0.1, and lift rate is 5. The F1 score, the validation is 0.6973. The final test accuracy is same, 0.6973. To optimize performance, hyperparameter tuning was performed on the best model CatBoost with ANOVA F-test using 30 features. Using the grid search CV method, the optimized parameter included depth, iteration, learning rate, and L2 regulation. The tuning results show the optimal configuration, which improved model stability and produced the highest F1 score of 0.9673 in validation, and 96.73% accuracy in the test data. This proved that the model remained efficient and competitive compared to complex approach in previous literature. And for the sub-explanation, to ensure transparency in model decision, sub-sepally additive explanation analysis was performed to identify the most influential features. The result shows that features such as Google Index, PageRank, NB underscore 3W, and NB hyperlinks consistently have the greatest contribution in distinguishing between phishing and legitimate URLs. These findings not only validate the feature selection results, but also strengthen the interpretability of the model. Thus, The model is not only accurate and efficient but also trustworthy by explainable AI. An important aspect of the application of cybersecurity system in the real world. So for the conclusions, the study provides a comprehensive evaluation of various feature selection techniques in machine learning based phishing site detection system. The result of the experiments show that filter-based methods such as ANOVA F-test can significantly improve model efficiency without sacrificing accuracy, with a performance decrease of less than 1% compared to the model without features reduction. The combination of CatBoost and ANOVA F-test with 30 features produced the best performance with an accuracy of 96.73% and an F1 score of 1.9673 after hyperparameter tuning. In addition to increase the accuracy, training time and inference time were drastically reduced, making the model more efficient for a real-world implementation. Explainability analysis using subs also shows that features such as Google Index, PageRank, and NB Hyperlink have the greatest influence in distinguishing between phishing and legitimate URLs, thereby strengthening the transparency of the model decisions. Overall, this research confirms that the integration of feature selection and explainable AI not only improve performance and efficiency, but also strengths the reliability, and the scalability of the modern phishing detection system. And for the limitation and future work, the first one is use another dataset because we only use one dataset from open dataset from Kaggle. You such as like UCI or Pstank. And the second is add energy analysis and robust adversarial testing. And the third one is to integrate feature selection with deep learning or meta heuristic hybrid. So this is the end of explanation from our experiment. The last words I can tell to you all is thank you for listening to my explanation. Thank you.